In order to integrate x squared minus 2x minus 5 over x minus 1 squared times x squared plus 1 dx, the first thing we're going to need to do is find the partial fraction decomposition for this thing. And we'll do that then by putting a constant over the first linear factor and then a constant over the repeated linear factor, and then a linear numerator over the quadratic factor in the denominator, and then of course set that equal to the whole thing. Multiply, clear the fractions out, and we're going to wind up with a times x minus 1 times x squared plus 1 plus b times x squared plus 1 plus cx plus d times x minus 1 squared. Of course, that's going to equal x squared minus 2x minus 5. And then I am skipping a little bit here in the process of multiplying this out, multiplying these factors out here. But in the end, what we're going to wind up with is a plus c times x cubed plus minus a plus b minus 2c plus d times x squared plus a plus c minus 2d times x, and then minus a plus b plus d is then going to be equal to x squared minus 2x minus 5. And since we don't have an x cubed term over here on the right, then this factor in front of x cubed must be 0. So a plus c must be equal to 0. And since our coefficient on x squared is a minus 2, or rather is a 1, then we know that minus a plus b minus 2c plus d must equal 1. Our linear coefficient is minus 2, so a plus c minus 2d must equal minus 2. And then our constant term then is going to come from the minus a plus b plus d, and that should equal minus 5. And so we set up this set of linear equations with 4 variables and 4 equations, and solve for each variable. We'll wind up with a is 3, b is minus 3, c is minus 3, and d is 1. This allows us then to set up our integral as 3 over x minus 1 minus 3 over x minus 1 squared plus minus 3x plus 1 over x squared plus 1. So there's our a, our b, and our cx plus d, integrated with respect to x. And probably the easiest way to do this is going to be to break it up into 3 integrals, because we have 3 terms here. So we'll have the integral of 3 over x minus 1 dx minus the integral of 3 times x minus 1 to the minus 2. So I'll rewrite this thing so it'll be a little easier to look at as we integrate, and then with respect to x. Plus, and then I rewrote this as minus 3x plus 1 times 1 over x squared plus 1 dx, because we're going to realize that this right here is a couple of factors that appear to be completely unrelated. And so then we start thinking about doing our integration by parts for that term. This term integrates to 3 times the natural log of the absolute value of x minus 1 minus 3 times, and then we integrate this thing, and we're going to have x to the minus 1 over minus 1 plus this thing that we're going to integrate by parts. Okay, so here we go. We're going to look at this and say, okay, this is that format that I want to use in order to do this integration. So I'm going to have dv be this 1 over x squared plus 1. And we recognize that because its integral is just the inverse tangent. And then u will be this minus 3x plus 1, and that derivative will be minus 3 dx. So everything is really pretty handy as far as this thing goes here. So we integrate this thing, we're going to have minus 3x plus 1, inverse tangent x minus inverse tangent x times minus 3 dx. uv minus integral v du. And that's going to give us then these, if I multiply this out, I'll have minus 3x inverse tangent x plus inverse tangent x. I can bring this 3 and minus 3 out front, multiply it by the minus, and I'm going to have plus 3 times the integral of minus tangent x dx. Now that integral right there is x inverse tangent x minus 1/2 natural log 1 plus x squared plus c. So I'm introducing our constant of integration now, since I've handled all of my integrals. So we have minus 3x inverse tangent x plus inverse tangent x. Now if I multiply this 3 through here, I'm going to have 3x inverse tangent x minus 3/2 natural log 1 plus x squared plus the constant. And what we realize is that these terms will cancel out, and we'll wind up with inverse tangent x minus 3/2 natural log 1 plus x squared plus c. But we have to remember what we're doing. We're actually integrating that first function, which we did in 3 parts. The first part gave us 3 times the natural log of absolute value of x minus 1. The second part gave us 3 over x minus 1. And now the third part gives us inverse tangent x minus 3/2 natural log 1 plus x squared plus c.